Assalamualaikum. Today our group will be talking about chapter 3, redox titration. What is the definition of redox titration? Redox titration is a reaction involving both reduction and oxidation, and it can be defined based on transfer of oxygen, transfer of hydrogen, transfer of electrons, changes in oxidation number. First, we have transfer to oxygen. From oxidation side, it will gain of oxygen, and from reduction side, it will loss of oxygen. As we can see here, the from oxidation side, it gains an oxygen atoms, and from reduction side, it lost 3 oxygen atoms. Next, we have transfer to hydrogen. Transfer to hydrogen, when oxidation, it will lose hydrogens, and reductions gains of hydrogens. As we can see here, the oxidation lost 6 hydrogen atoms and reduction gain 6 atom. Next, we have transfer to electron. Transfer of electrons from the oxidation side is a loss of electrons, and from reduction sides we gain of electrons. From example, we can see here's magnesium donates electrons to oxygen and its lost electrons, while reduction sides oxygen accept electrons from magnesium and its gain electrons. Next, we have transfer to oxidation numbers. On oxidation sides, the oxidation number will increase, while reduction sides, the oxidation numbers will decrease. For example, we can see the oxidation side, it's increased to 1, and from reduction side, it's decreased to -1.
Let's move on to the subtopic 4.2, oxidation number of elements in compounds. Each atom in a molecule or ionic compound is assigned an oxidation number or oxidation states. The number of charges the atom will have in a molecule if electrons were transferred completely. This is the rules to determine oxidation numbers, and I will tell you guys more so you guys can understand better. Next one is element by itself. So element by itself is with no combination with other elements, such as we see here chlorine, sodium, sulfur, phosphorus. It is by itself with no other elements, so the oxidation number is 0. For monatomic ion, we need to find the oxidation number by its ion charge. So K plus its ion charge is +1. And nitrogen 3 minus 3. Magnesium is 2 plus and +2. So the ion charge is the oxidation number is based on its ion charge. The next one is group 1A. Okay, group 1A is always positive 1, this one. And group 2A is always positive 2, this one. And halogens, usually -1, positive with oxygen. And hydrogen is +1 with non-metals, -1 with metals. Fluorine is always -1. You need to remember that. Oxygen is usually -2, -1 in peroxide H2O2. So sum of oxidation numbers for a natural compound is equal to 0, and sum of oxidation numbers for polyatomic ion is equal to ion charge. So let me tell you guys more. So for this question here, KCl. So we know that KCl is in group 1A. So the oxidation number for kalium here is +1. And chlorine, we know that it is in group halogens, so -1, equal to 0 because this one is natural compound. Same goes for this question, MgO. So Mg, we know it is in group 2, always plus 2, and oxygen, we know that oxygen is usually negative 2, so equal to 0, because this one is neutral compound. This is the question on how to calculate oxidation number, and I will explain it to you guys so you guys can understand more. For the first question here, we have find the oxidation number of C in sodium carbonate. So we know that sodium is in group 1. So the oxidation number of sodium is plus 1. Plus 1 times 2 because sodium here have 2 plus C because we need to find the oxidation number of carbon plus 3 times negative 2 equal to 0 because oxidation number of oxygen is negative 2 and times 3 equal to 0 because this one is neutral compound. So we do the calculation, we got carbon plus 4. So oxidation number for carbon is plus 4. The next one is find the oxidation number of manganese and manganese in permanganate ion. So here we put Mn plus 4 times negative 2 because we know the oxidation number for oxygen is negative 2 equal to negative 1 because why? This one is polyatomic ion. So for the sum of this is equal to its ion charge. So ion charge here is negative 1. So equal to negative 1. And then we do the calculations. We got manganese equal to plus 1.
And now we move to the chapter 4.3, reducing and oxidizing agent. There are two types of agent, reducing and oxidizing agent. Reducing agent means the species which is being oxidized itself, electron donor. Meanwhile, oxidizing agent is the species which is being reduced, electron acceptor. Reducing agent causes reduction and it is oxidized, also loses electrons. Meanwhile, oxidizing agent causes oxidation. It's reduced and gains electrons. So there are tips for identify the substance oxidized and reduced. Oxidized substance was reducing agent and reduced substance was oxidizing agents. Firstly, Fa2 plus to Fe3 plus, we can see the charge increase, so it's oxidation, which means it's reducing agent. Next, NO3 1 minus to NO2. Remember, NO3 1 minus were in negative charge, so the NO3 1 minus equal negative 1. Next, O were negative 2 times 3 will get negative 6. Then to get N nitrogen, negative 1 will move forward become plus 1 with negative 6. Then the answer for N is positive 5. For NO2, O was negative 2 times 2 will get negative 4. But NO2 in neutral compound, they become 0. To get N nitrogen, negative 4 equals 0. N will become positive 4 to get 0. Lastly, positive 5 to positive 4 means they decrease. So that means they are reduction. And reduction was oxidizing agent. But how about 3H plus become H2O? For 3H plus become H2O, H plus is neither an oxidizing agent nor a reducing agent. Why? Because oxidation number for 3H plus and H2O were positive 1. What does this mean? It means hydrogen does not lose electron and not gain electron. There's no oxidation and reduction. Basically, H plus is not an oxidizing agent or reducing agent.
Okay, so now we go to the last subtopic, which is 4.4, balancing redox reaction in acidic medium. Some equations for oxidation reduction reactions can be easily balanced by inspection. However, it is often easier to balance the oxidation reduction reactions by the half reaction method. This method is based on the principle that all the electrons lost in an oxidation half reaction must be gained in a reduction half reaction. Okay, so we need to do the half reaction so that we can describe either the ionic equation is gaining or losing electrons during redox reactions. As you guys can see, this is the example of oxidation and reduction. So, number of electrons transferred for both oxidation and reduction reactions must be in same value. So this is the 5 steps to balancing redox reaction in acidic medium. So first, separate the reaction into half reactions. Determine the ON for species undergoing redox. Second, balance atoms and charges in each half reaction. Third, multiply each half reaction by an integer. Add the half reactions together, cancelling substances that appear on both sides. And last one is check that atoms and charges balance. So now let's we see the example. Balance the redox reaction in acidic medium. So first, we need to determine the ON or oxidation number. So there are the solution. So the oxidation numbers of the elements were determined to identify oxidation and reduction. As you can see, chromium changed from plus 6 in Cr2O7 to plus 3 in Cr3+, indicating reduction, while iodine changed from minus 1 in I negative to 0 in I2, indicating oxidation. So now, step 2, balance atoms and charges in each half reaction. In this step, atoms and charges in each half reactions were balanced. Water or H2O was added to balance oxygen atoms. Hydrogen ions H plus were used to balance hydrogen atoms, and electrons were added to balance the charge. So step 3, multiply each half reaction by an integer. The oxidation half reaction was multiplied by 3 to equalize the numbers of electrons in both half reactions so that the electrons can be cancelled. Okay, step 4. Add the half reactions together and cancelling substances that appear on both sides. The oxidation and reduction half reactions were added together and the electrons that appear on both sides were cancelled to obtain the overall equation. Okay, last step, the final equation was checked to ensure that all atoms and charges were balanced on both sides of the equation.